Hello and welcome back to another video. This problem we're asked to find the derivative of f of x, not using the power rules that we've been using so far in this section, but using the definition of a derivative, which we learned in the last chapter. So the derivative, as defined, is the limit as h goes to 0 of f of x plus h minus f of x over h. Okay? So now we can just plug in for 1 over x and we can solve it, and we should get that the derivative is equal to negative 1 over x squared. So what is f of x plus h? Well, plugging in x plus h over here, we get 1 over x plus h. F of x, don't have to plug in anything, we already know it, and h is the same. You have to make sure that you keep the limit, otherwise you're going to be left with some h's in your final equation, which you never want. Now this is something we can simplify. So you limit as h goes to 0. We want to deal with the top first. We want to get a common denominator. So we multiply this by the denominator of this, and this by the denominator of that. Eventually they will have the same denominator. So x over x times 1 over x plus h. Again, this is equal to 1, so you're not actually changing the value, so that's why you can do that to get a common denominator. Times x plus h over x plus h over h. Again, doing the same thing here. You'll see why if you don't already, because now we have x times 1 is x over x times x plus h minus 1 times x plus h is x plus h over x times x plus h over h. Again, this looks really complicated, but since these have the same denominator, you can subtract the numerator. So we have x minus x plus h over this is x squared plus xh, and this is divided by h. So we have the limit as h goes to 0 of x minus x is going to be 0 minus positive h is minus h over x squared plus xh. And this is divided by h, and this is going to be a little bit easier to solve if we think of it as multiplying by 1 over h. Since dividing by h is the same as multiplying by 1 over h, we can do that. And the reason we did that, because now we can see more clearly that these cancel. And with the limit as h goes to 0 of negative 1, don't forget that negative, over what we had left down here, which is x squared plus xh. Now, in the beginning, we could not plug in 0 right away for h because it was in the denominator. Now it is in the denominator, but the denominator won't be 0 when we plug it in. So you can plug in the limit as h goes to 0 of this is equal to negative 1 over x squared plus x times, plugging in for 0. There we go, x times 0. So we get negative 1 over x squared plus 0 is equal to negative 1 over x squared, which, as we want, is equal to the derivative of x. Again, this proves the power rule for case n equals negative 1. As always, thank you for liking and subscribing, and I will see you in the next video.